Okay, let's have a look now where we left off. Mm, mm. Um, let's see. I know we did some XY stuff last time. Okay. For the following exercises, draw the given optimization problem and solve. Find the volume of the largest right circular cylinder that fits in a sphere of radius 1. Find the volume of the largest right cone that fits in a sphere of radius 1. Okay, well, I don't know how long this one will take. Let's have a look at 341. Okay. See how good or bad this is. Find the volume of the largest right circular cylinder, okay, that fits inside a sphere of radius 1. So there is the cylinder, and it has to fit inside a sphere of radius 1. So I think that would mean that this diagonal here is 1 unit. So this here has a height h, and that's a radius of r, and that there is half the height, h over 2. So we know that h squared over 4 plus r squared has to equal 1. And the volume is pi r squared h. So that would be pi 1 minus h squared over 4h. So that would be pi h minus pi h cubed over 4. So dv dh is pi minus 3/4 pi h squared needs to equal 0. Cancel pi's and you get 1 equals 3/4 h squared. So h would be the square root of 4 over 3. So h is 2 over root 3. So h is 2 root 3 over 3. Now we can check that that is the largest. So the second derivative is a negative. We can see it's negative, which makes it a max. Boundary conditions don't quite make sense here. Like h is 0. It just would, yeah, so I don't think there's any point in checking the boundary conditions. Let's see the answer at the back. Hopefully we are, oh no, we want the volume. So not quite finished yet. So the volume would be pi 1 minus h squared. 1 minus h squared. So that's, what's that now? Sorry, 4 on the bottom as well. And then it would be 439 times h, which is 2 root 3 over 3. So the 4's cancel. So that's 1 minus a third. So that's 2/3. Pi 2/3, 2 root 3 over 3. So that would be 4 over 9 root 3 pi. Let us see. This is question 341. 341. 4 pi. Oh, okay. 4 pi, and they left it like this, 3 root 3 at the bottom. So, okay, if I divide by root 3, that'd be root 3. So it seems like I have an extra 3 when I shouldn't have. Why is that? Why is that? They have 3 root 3. I have the 4 pi. That's the h. H squared is 4 3 over 9 over another 4. 1 over 3, 1 minus 2/3 times the h. 2 over 3 over 3. 2/3. 2's make the 4. 3's make the 9. What about if I just kept it in that form? Maybe I'm doing something wrong with my surds. If I just kept it as root 4 over 3, that'd be better. We can see that dh squared is negative, so that makes it a max. And then the volume would be pi 1 minus a quarter times h squared, which is 4 over 3 times h, which is 4 over 3. So that'd be pi minus a third, so that's 2/3. And then that's root 4 over 3. So that's, yeah, 4 pi over 3 root 3. Yeah, okay, that's fine. That's fine. Let's have a look at the next one now. Oops. 342. Wonder if I can fit it in here. Find the volume of the largest right cone. So the cone, so what's the only difference here? No, not quite like that. Cone is like this. So we still have the or, and we still have the h, but the formula is a little bit different. Or squared plus h squared. Okay, the cone's a bit different. Yeah, the cone goes up to the top. Okay, there's the sphere. The cone will be like this. So, that's the radius. That's the height. Let's see. And then this has to be a 1 from where though exactly here? This is a chord. Ooh, this one's trickier. Okay. It's not a great picture. Okay. So, right. Height and radius. Some point here to here is a 1. So maybe we could call that x and that y. I don't know if this is going to be helpful. So x plus y equals the height. And x squared plus r squared has to equal 1. Definitely don't want to have x and y here. I can at least replace the x with a y, but no, that's not enough. That's not enough. Oh. Okay, I also know that y is equal to the radius here. So if I sub that in there, I can get x plus r equals h, and x squared plus r squared equals 1. And if I sub that in there, I can get h minus r, h minus r squared plus r squared equals 1. So that's a little bit messy, messier than I would like it to be. This is basically y equals r. So that's x plus r equals h. Then x squared. Oh no, hang on. Yeah, x squared plus r squared. Oh no, sorry, that's not the it's the radius of the sphere, which is 1. So that's a 1, not an r. So y equals 1. So that means x plus 1 equals h. So that means h minus 1. Okay, so let's square that out. H squared minus 2h plus 1 plus r squared equals 1. The 1's cancel, and you get r squared equals 2h minus h squared. Now that might be useful. So the volume is 1/3 pi r squared h. So that'd be 1/3 pi 2h minus h squared h. So that's 1/3 pi 2h squared minus h cubed. So that is 2/3 pi h squared minus 1/3 pi h cubed. So dv dh would equal 4/3 pi h minus pi h squared. And that needs to equal 0, which means that has to equal that, which means the pi's cancel, h can't be 0. So you get h is 4/3 pi. The second derivative is 4/3 pi minus 2 pi h. And if I sub that in, you'll get 4/3 pi minus 8/3 pi squared, which is a negative, which makes it a maximum. So if I just put that back into the volume here, so the volume is 1/3 pi twice the h, just h/3. Oh, Stephen, there's no pi here because they cancel. It's just 4/3. I thought that square was a bit suspect. So that means there's no pi there. So that's better. Okay, so that's good. And then 8/3 minus 16/9 times 4/3. So 8/3 minus 16/9 times 4/3 times 1/3. So that volume is 32/81 pi. Okay. Right. No way to check the answer at the back because it's an even question, but I think it's right. I think it's right. I fixed my mistake with the pi. So the height of this will be slightly more than 1. So yeah. Yeah, so my picture's kind of close to what the right answer is. Okay, that's kind of a tricky one. So, but yeah, I think we'll leave it there for today.